Hi, welcome to Backer Breaks It Down. In this episode, we continue to work with short-run behavior of polynomials with a focus on sketching polynomials, which is something I really enjoy doing. Okay, so how do we sketch a polynomial? Okay, so first off, multiplicity and X intercepts. We talked about this in our last episode together. When we have a function written in factored form, it's really easy to identify the x-intercepts, okay? Because I just have to look at the factor itself. So if the factor is like written like x minus a number, so x minus k, that means k is an x-intercept, right? Now the exponent of that factor is called multiplicity, right? And that multiplicity tells us what exactly is happening at that x-intercept. And so if it's an even multiplicity, that means like at the x-intercept, the graph is touching the x-axis and bouncing off. And if it's an odd multiplicity, then it's crossing the x-axis and bouncing off. So if you look at this example here, the factor x plus 1 quantity squared tells me the x-intercept, or the 0, is -1. And since the multiplicity is 2, that it touches the x-axis and bounces off. And that is like exactly what's happening right here at -1. The factor x minus 2 quantity cubed tells me that the x-intercept is 2. And since the multiplicity is 3, it's crossing the x-axis at that point. Okay, now look at how it's crossing, right? It's like crossing, it's kind of flattening out. So it's not crossing like straight through. It's crossing kind of like a cubic function does, as opposed to like straight through like a linear function. And if you think about it, like makes sense, because isn't that like x cubed? Doesn't it do that? Doesn't it have that behavior? And now this like x minus 2 quantity cubed is like having that same behavior. Okay, so that's kind of interesting. We're seeing that similar behavior that we saw when we studied power functions. Okay, but more on that like later. I just want to focus on making a rough sketch. Okay, so definitely like from the factored form, you can easily identify what the x-intercepts are and like what is happening there. Is it crossing or is it touching? Okay, end behavior. Like we can use the leading term test to determine end behavior. So the leading term is the term with the largest like exponent when it's written in standard expanded form. When it's written in factored form, I need to like figure out what the leading term is. So I did that here. So remember, like when it's in factored form, I'm like, ooh, what's the leading term of each factor? So that first factor has a leading term of x of degree 2, and the second factor has a leading term of x of degree 3. So when I put those two factors together, like, and I multiply x squared times x cubed, I get x to the 5th. And that's odd and positive. And that's how I determine the end behavior to be negative infinity on the left, positive infinity on the right. You might need to revisit the notes from 11.2 if you've forgotten your end behavior. And then the Y-intercept. So the Y-intercept of any function can be found by calculating f of 0. So like literally plug in 0 for x and calculate. And so I did that. Plugged in 0 for x in both places, calculated, I got -8. And so I can put all of these things together and I can create like a rough sketch of a polynomial. Okay, excuse me, sorry. So let's do this, okay? Let's analyze this polynomial, let's sketch it. So in number 3, I have the function -4 times the quantity x plus 2 times the quantity x minus 1. So I need to figure out end behavior, all right? So it's factored form, so I need to look at the end. I need to look at like what's the leading term of each factor. So the leading term of the first factor is -4. The leading term of the second factor is x. And then the leading term of the third factor is x squared. So if I put all 3 leading terms together, I'm calculating Like, what is negative 4 times x squared? And the answer is it's negative 4x cubed. Okay, so that's my leading term. This leading term is odd degree, and then it's negative. And all odd negative polynomials have an end behavior on the right of positive infinity. And I'm sorry, on the left is positive infinity, and on the right is negative infinity. For my x-intercepts, this is where I use that zero product property on my x factors. So one of my x factors is x plus 2. So this x factor tells me I have a 0 at negative 2. The multiplicity of that factor is 1, and since 1 is odd, it's going to cross the x-axis. My second x factor is x minus 1 quantity squared. X minus 1 tells me I have a 0 at 1. The multiplicity of the factor is 2. That's the exponent. 2 is even, so that means it touches the x-axis. For the y-intercept, I'm going to calculate off of 0. So in my calculator, I will type like negative 4, and then in parentheses 0 plus 2, and then in parentheses 0 minus 1 squared. Okay, so when x is 0, I get negative 8. Okay, so now let's put this all together. So the first thing that I like to do is I like to plot all my intercepts. Okay, so I've got an x-intercept of negative 2. I have an x-intercept of 1. And I have a y-intercept of negative 8. The next thing that I like to do is my end behavior. Okay, so I know that on the left, it's going to go to positive infinity. So I'm just going to go over here to the left side and go up positive infinity. And then on the right side of the function, it's going down to negative infinity. So I'm going to go all the way to the right and go down to negative infinity. Okay. So now we need to kind of fill in what's happening in the middle. All right. So now that's where I need to focus on what's happening at each x-intercept. So let's start with the x-intercept of negative 2. Okay, the x-intercept of negative 2 crosses the x-axis. So like I do need to show it crossing. Okay, and if you can imagine, it's like going to connect to my left end when it does that. Okay. When it comes to 1, the x-intercept of 1, I need to show it touching the x-axis. So like I can make that connection to my right end behavior and show it touching. Right, so it's just like what's happening in the middle now that like, it's like, well, what's going on there? And the only thing I know that's happening there is that like it has to go through my y-intercept and like connect. Okay. And so this is my really rough sketch of this function. Okay. So I'll just like smooth it out for you. Okay. But it really does show everything, right? It's showing that on the left, like that it's going up to positive infinity. That on the right, it's going down to negative infinity. It's showing that at negative 2, that it's crossing the x-axis. That at positive 1, it's touching the x-axis. And it's showing that y-intercept. So it's showing all the behavior. How accurate it is, we need calculus for that, but like it's pretty darn good. In this problem here, they describe a polynomial for us, and they want us to sketch it. So it's a little different because they didn't give us the function. They are telling me that on the left end of my function, the end behavior is negative infinity. And on the right end of my function, the end behavior is positive infinity. They're indicating that the Y-intercept is 0, 30. So it'll be on the positive end. One of my zeros is 2, and it has a multiplicity of 2. So what does that mean is going to happen there? Yeah, that means it's going to touch. And then my other 0 is negative 3. It has a multiplicity of 1. So it's going to cross. So now I just need to put that in there, okay? So I have a 0 at positive 2. I've got another one at negative 3. Okay, and then I just need to show that behavior at the x-intercept happening. So starting here at 2, I know it touches. So if I go for my right end behavior and I touch at 2 and I bounce up, that will show that touching behavior. I know at negative 3 it needs to cross. So if I go from my end behavior on the left, I can cross at negative 3. And then all that's left for me to do is to fill in what's happening around the y-axis. So it still has to go through my y-intercept of 30 and then connect to the other side. So if I were to smooth this out, make it look a little bit nicer. How does that look? Nice. And it's showing everything. I've got negative on the left, positive on the right. I've got the y-intercept of 30. At 2, it's touching, and at 3, it's crossing. So I've got everything there. And if you're wondering what the actual function formula is, the next lesson totally answers that. Okay, but this is how you graph a polynomial function from its factored form. So we want to use the leading term test, identify what that leading term is, and define your end behavior. You can find the x-intercepts by using your zero product property and multiplicity to determine whether it touches, so even multiplicity, or crosses the x-axis odd multiplicity. And then, of course, the y-intercept can be found by calculating f of 0. And that's how Backer breaks it down.